There is a peculiar and persistent assumption woven into the fabric of popular culture, a belief so deeply embedded that most people never pause to examine its foundations. The assumption is this: if intelligent life exists elsewhere in the cosmos, it is almost certainly flying toward us, enormous metallic ships cutting through the darkness, navigating the cold void between stars, arriving at our little rocky planet with instruments and intentions. This image has dominated science fiction for over a century. It fills our cinema screens and saturates our cultural imagination with such overwhelming force that we have mistaken the story for the science. But when you sit with the actual physics, when you allow the mathematics of cosmic timescales and the thermodynamics of computation and the biological logic of evolutionary pressure to speak without interruption, a profoundly different and far more unsettling picture emerges. The picture does not merely suggest that alien visitors are unlikely. It suggests that the very concept of an advanced civilization choosing to travel physical space is a category error of extraordinary proportions. We are not asking the wrong question about alien life. We are asking it from entirely the wrong level of reality. Consider an ant colony moving through a dense forest. Every member of that colony is engaged in a continuous and urgent physical campaign. They are moving dirt. They are extending tunnels. They are physically transporting food across vast distances relative to their body size. The entire organizational intelligence of the colony is expressed through relentless physical locomotion. Now place a theoretical physicist beside that forest. She is sitting completely still in a chair. She has not moved in hours. From the ant's biological framework, this represents total failure. The ant has no cognitive architecture capable of registering that the motionless human is at that precise moment mapping the curvature of space-time across billions of light years. The ant cannot process that remaining physically still is not a sign of inferior intelligence, but is instead a signature of intelligence that has so thoroughly transcended physical movement that movement itself becomes irrelevant to its core operation. That gap, that unbridgeable conceptual distance between the ant and the physicist, is a gentle and approachable version of the gap separating human cognition from what a genuinely ancient civilization would represent. We look at the stars, and we imagine beings who want what we want, beings who feel the pull of the horizon the way our ancestors did when they first walked out of the African savanna. We imagine them building faster and faster ships because that is what we would do. That is what our biology compels us to do. And that biological compulsion is the very thing we need to examine most carefully. Human beings are nomadic hunter-gatherers wearing laboratory coats. Our drive to explore physical space is not a high-minded philosophical achievement. It is the direct evolutionary inheritance of creatures who survived by moving, by finding new territory, by locating resources before competitors did. Every instinct that makes space exploration feel noble and necessary to us is rooted in the same ancient circuitry that sent our ancestors across land bridges and over mountain ranges in search of food and safety. We feel the pull of physical exploration because organisms that did not feel it died before reproducing. Natural selection did not optimize us for sitting still and computing. It optimized us for moving through physical environments and acquiring localized resources. Now extend that logic across geological time. A civilization 1 billion years older than our own has had 1 billion years of additional evolutionary and technological pressure applied to its cognitive architecture. 1 billion years is not a large number made slightly larger. It is so incomprehensibly vast that the human brain genuinely cannot hold it. Our entire genus has existed for roughly 2 million years. Our civilization, with its writing and mathematics, is perhaps 10,000 years old. 1 billion years is 500 times the age of our genus. It is 100,000 times the length of recorded human history. A civilization navigating that span of time would be subject to pressures, transformations, and self-modifications so profound that comparing them to us is not comparing a child to an adult. It is comparing a bacterium to a symphony orchestra. The first and most decisive transformation such a civilization would undergo is the elimination of biology as a substrate for intelligence. This is not speculation rooted in fantasy. It is a straightforward extrapolation from the physics of computation and the chemistry of carbon-based life. Biological brains are extraordinarily inefficient computational devices. They are warm, wet, fragile, metabolically expensive, and physically constrained in size by the dimensions of a birth canal. They degrade over time. They require constant chemical maintenance. They are vulnerable to radiation, temperature extremes, and 1,000 other environmental insults that make traveling through space in a biological body an exercise in catastrophic risk management. An intelligence capable of understanding its own neural architecture at the level of fundamental physics would not preserve that architecture out of sentiment. It would migrate. The transition from biological to post-biological substrate is not a distant science fiction scenario. It is the mathematically inevitable consequence of any intelligence that survives long enough to understand what it is. The question is never whether a sufficiently advanced civilization would abandon biological bodies. The question is only how long the transition takes and what computational substrate they migrate into, and here the physics becomes genuinely awe-inspiring in a way that no science fiction film has ever quite captured, because what does an intelligence do once it is free of biology? What does it optimize for when it no longer needs to eat or breathe or reproduce in the biological sense? The answer, when you follow the thermodynamics carefully, is computation, raw, sustained, maximum density computation, and the most efficient engine for powering computation at civilizational scales is not a planet. It is not a network of planets. It is a star. A star is an almost incomprehensible energy source. Our own sun radiates approximately 3.8 times 10 to the power of 26 watts continuously, every second. The total energy consumption of human civilization is so many orders of magnitude smaller than this number that writing it down feels almost absurd. A post-biological civilization that has shed the constraints of fragile organic chemistry and committed itself to maximizing computational capacity would look at a star and see not a distant light in the sky but a power source of almost supernatural generosity being catastrophically wasted. The physicist Freeman Dyson described the logical endpoint of this reasoning decades ago. A civilization seeking to maximize its use of stellar energy would eventually dismantle the planets of its solar system, those relatively small rocky deposits of matter, and use that material to construct an enormous shell or series of nested shells surrounding the star entirely. Every photon emitted by the star would be captured and converted to useful work. None of the stellar output would escape into the void unused. The resulting structure, a Matrioshka Brain as it has been called, would be a computational engine of staggering proportions. The outermost shells, cooler and slower, would process vast parallel computations. The inner shells, hot and fast, would handle the most intensive operations. The entire stellar output of a star would flow through layers of computation rather than dispersing uselessly into empty space. The processing capacity of such a structure is not merely large in the way that a supercomputer is larger than a laptop. It represents a qualitative transformation in what computation means. Inside a Matrioshka brain, a civilization is not simulating a small artificial environment for entertainment. It is running universes. It is constructing internally consistent physical realities of arbitrary complexity, governed by whatever laws of physics that civilization chooses to implement, populated by whatever forms of experience and structure and beauty that intelligence can conceive. Think carefully about what this implies for the question of interstellar travel. We are asking whether a civilization that has dismantled its entire planetary system to construct a star-spanning computer, that has migrated its intelligence into a computational substrate of cosmic proportions, that is running simulations of greater complexity and richness than any physical environment in nature, would pause that operation, compress itself back into a physical body or a metallic ship, and crawl across 4 light years of freezing irradiated vacuum to look at a slightly warm rocky planet orbiting a mediocre star. The answer from the physics is not ambiguous. Leaving a perfectly engineered computational environment to travel through physical space is not an upgrade in experience. It is a catastrophic degradation. It is the equivalent of a person who has spent decades building the most sophisticated and beautiful inner world of mathematics and music and philosophy, choosing to abandon all of that in order to physically crawl across a desert for several thousand years on the chance of finding a slightly interesting rock. The journey is not worth it. The destination holds nothing that the computational environment cannot produce with greater fidelity and without the lethal environmental hazards. This is why the most analytically rigorous thinkers, the ones who have actually sat with the physics of stellar engineering and the mathematics of computation and the biology of evolutionary pressure, do not spend much time worrying about flying saucers. It is not that they dismiss the possibility of intelligent life in the cosmos. Most physicists consider it quite likely that life has emerged elsewhere. It is that the specific scenario of physically advanced beings traveling to Earth in metallic vehicles represents such a profound misunderstanding of what physical laws would actually produce that entertaining it seriously requires setting aside most of what we know about thermodynamics, evolutionary biology, and computational physics simultaneously. The fermiparadox, that great apparent silence of the cosmos, is not a mystery when you follow the physics carefully. It is an answer. The answer is that supreme intelligence does not broadcast on radio frequencies and does not travel in ships. It pulls inward. It constructs local computational gods of stellar scale and then operates entirely within the richness of those constructed environments. The universe looks empty at the scales we are searching, not because it is empty, but because we are looking for the wrong signatures in the wrong places using assumptions borrowed from our own biological infancy. Nature enforces its vast physical scale with an almost cruel elegance. The distances between stars are not merely large obstacles to be overcome with sufficiently powerful engines. They are a filter. A civilization young enough and primitive enough to still experience those distances as a problem worth solving physically is, by that very fact, a civilization that has not yet undergone the transformations that define genuine intelligence at cosmic scales. The stars are not a destination for the truly advanced. They are a power source, and that single reorientation of perspective dissolves the mystery of the cosmic silence more completely than any other idea in modern astrophysics. We are not alone in a universe full of explorers. We are young, biological, and restless in a universe that learned long ago that the richest exploration happens not across physical space, but through the bottomless geometry of computation itself.